So I was saying, if you know the table of Laplace transforms, you don't really have to go through the initial step of saying Laplace transform of, let's say you have a function of t, f of t is equals to, we are going to have the integral from 0 to infinity of e to the minus st by f of t dt, like that. So you don't really have to go through you like going, like integrating step by step. If you are able to remember what uh, the transform of, let's say, t to the n is from the table of Laplace transforms, you can just go ahead and write it as an answer. Please, let's just mute our mics unless if you're asking a question. Okay, so these questions that you have here, they are very simple. Some of them is just a matter of expanding. For example, if you look at um, question question 1a, there is just a matter of expanding. Okay, it's just a matter of expanding. So I think it's important that we remember standard transforms. Let's say the transform of let's say t to the n, we say it's equals to n factorial divide by s to the n plus 1. Then the transform of a constant, let's say k, this is just going to be k over s. Okay, then one thing again to note is that if you have, let's say, k by f of t, your Laplace transform is just going to be k by Laplace transform of f of t, like that. Okay, so you don't find for both, then you multiply them together, your answer is going to be wrong. So the part where you only multiply is when you start looking at step functions. You'll be able to see that. Then another one that is perhaps common is the transform of, let's say, sine 80, which is equals to a divided by s squared plus a squared. In a similar manner, the transform of cos 80, which is equals to s divided by s squared plus a squared. What about the transform of e to the 80? This is equals to 1 over s minus a. So there are just a number of them that we can mention. So as long as you're able to remember any of these, and it's one of those questions that you have to answer, you can just go ahead and write the answer as it is. Okay, but of course for question one, there are a few here where we have to apply some theorems. There are two theorems that I can talk about before we even start answering. There is something we call the frequency shifting. Okay, the frequency shifting, or sometimes it's called the exponential scaling. Okay, exponential scaling. This is just a minute. Okay, so this, for the frequency shifting, this is basically when you have, let's say, e to the at, like that, by f of t. So it's like you're looking for the Laplace transform of the combination of these. So if you think of it in terms of the actual definition, it simply means it's more like you are saying, if you write it as an integral, it's the integral from 0 to infinity. Then here you're going to have e to the at, then you have f of t, then again you have e to the minus st dt, like that. So it's like you're going to have three functions, this one, as well as this one, which can be tedious, okay, for you to work out using just basic integrals. So no wonder we bring in these theorems to help us. So for such a scenario, how it is simplified is that we are just going to our answer is just going to be f of s minus what? F of s minus a. So what this means is that you're going to have to find the Laplace transform of your f of t. Then in that f of t that you get, I mean, in that, the Laplace transform of this, your f of t is going to be equals to f of s. So in that f of s that you're going to get, where there is s, you're going to substitute with what? With s minus a. So you just pick the a is coming from here. Whether it's negative or positive, you just pick it as it is. Okay, so that is that about the frequency shifting. Then the other one, the second theorem is called, is it frequency domain uh, domain derivative. Okay, so for this one, it's an arrangement where you have you're looking for the Laplace transform of, let's say you have t to the n by f of t, like this. Again, this one as well, if you see it as an integral, it's like from 0 to infinity. You have t to the n, whatever n is there. It can be a 1, it can be a 2. Then you have f of t here. For example, let's say it's sine 80. Then you also have e to the minus st dt, like this. So still, even that one is pretty tedious for you to work around with. So the frequency domain derivative is going to make our work much easier as we work around such an arrangement. Okay, so for this one, we're just going to say to be negative 1 to the power n. Then we're going to say f to the n of s. Okay. um, Okay, people who are joining late are really disturbing me. Okay, so these are the two important theorems that we really have to know, because you're most likely going to come across them as you look for Laplace transform of certain questions. So just have them at your fingertips. Okay, so I'm going to leave it up to you guys to choose from question one. You can choose three questions. No. Okay, you can choose two. Then we'll go to question two. So anyone to choose. We have A, B, C up to I. Someone to choose the first one will do. Then we'll continue in that order. Come again? Yes. Some. Is it Chiloko? Yes. Someone is raising their hand. That is I. Okay. So as we do I, someone else to think of the other one, then we'll come back to it. Okay. So I is hyperbolic cosine of 2t sine, we have hyperbolic cosine of 2t multiplied by sine 3t. Hope I'm right. Okay, so what we are going to do here is yes, Mary. Okay. Okay, so what we are going to do here is I'll take advantage of the fact that this one I can write it into its equivalent exponentials. So this is a hyperbolic function. So in terms of exponentials, if we have hyperbolic cosine of 2t, this is just going to be e to the 2t, is it, plus e to the minus 2t divided by 2, isn't it? Is this okay? Do we agree on this one? So here it will just be the matter of substituting. So it simply means where I have hyperbolic cosine here, I'm just going to replace with e to the 2t plus e to the minus 2t. We have divided by 2, and everything is multiplied by sine what? Sine 3t. Okay, so we're just going to have to expand here. So I can bring the 1 over 2 on the outside, meaning inside the brackets I can put e to the 2t sine 3t, then I'll say plus e to the minus 2t, then I put sine 3t, like that. Okay, so if we say we are looking for the Laplace transform of this, okay, so allow me to just put the 1 over 2 on the outside, so we can just put everything that's on the inside here, right here, like that. So one thing that you're able to observe here is that this is similar to one of the theorems that I was talking about, which is the frequency shifting or the exponential scaling. Okay, so if you observe, it's in the arrangement where you are saying e to the at multiplied by f of t. So when we said if you're looking for the Laplace transform of such an arrangement, this is just going to be f of s minus what? F of s minus a. So all we have to do is to pick our f of t, which in this case is what? Is this one. Uh, Mary, you are raising your hand. Others, are you able to see my screen? Okay, Mary, just leave the meeting, then rejoin again. Yeah, maybe it's just your network. Okay, so we said it's just a matter of noticing, like, we have to use our f of t to get our f of s. So from here, okay, this one or this one. And one thing again is about Laplace transforms is that if you are saying let's say Laplace transform of a plus let's say b, this can also be written as Laplace transform of a plus Laplace transform of what? Of b. So whether someone writes this one separate plus this one, or someone writes it the way I've written it like this, is still okay. Like, you're still going to get the correct answer. So what I'll do is that I'll pick my f of t. In this case, it's my f of t is sine 3t. Okay, sine 3t. So if we find the Laplace transform of this one, it's just going to be equals to, we said for sine, if you have sine at, the Laplace transform of this is just a over a squared plus a squared. In this case, our a is a 3. So we just put a 3 here, divide by, we say a squared plus what? 3 squared is a 9. That's what we put there. So keep in mind to say we now have this part, and that's where now we introduce what? The frequency shifting. Okay? So it simply means when we say Laplace transform of um, here we say e to the minus 2t, for example. Let me see, we add our sine 3t here like this, then we say plus again. Okay, by the way, I have 1 over 2 on the outside, 1 over 2 here, so I'm just going to write them as individual transforms. So here you have minus 2t, then sine what? Sine 3t. So this combination that I have here, let's see what is going to result into. So we have worked out what the transform of sine 3t is, which is 3 over which is 3 over s squared plus 9. So it simply means if you were to indicate to say where there's s in your f of s, because this is our f of s, we need to substitute with what? With s minus a. What is our a? Our a is the coefficient of t, like for this one, and for this one the coefficient is positive 2. So this is just going to be 3 divided by, we say open bracket, s minus your a, which is a 2, then squared plus 9. Then you put plus here like this. Then we're going to have um, 3 over s minus. But for this one, observe to say our a is minus 2, so this will just be plus 2 squared plus what? Plus 9. So by the way, everything here we have a 1 over 2 on the outside, so you can just put 1 over 2 then in your brackets, or if you want, in fact, let me just put this as 3 over 2. Then we have 1 over s minus 2 squared plus 9 plus 1 over s plus 2 squared plus 9 like this, and this is your solution. So what do we observe from this question is that when it comes to Laplace transforms, sometimes you just have to be quick in terms of manipulating questions so that they work to your advantage. Yeah, so I don't know whose mic is on, but it's disturbing me. Okay, so the frequency shifting, it can also be applied on question H, which is this one, as well as C and D, even G. But for G, it's up to you whether you're going to use the frequency shifting or the exponential. I mean, the frequency shifting or the frequency domain derivative. So, someone to pick the second question, we do it quickly so that we move to the next one. So, what other question do you want me to do before we go to the next one? Okay, if you're not picking, then I'll just go straight to the next question. Okay, so and again, maybe just to talk a little bit about question one. Question 1E and 1F. These, remember that you need to apply the addition and subtraction formulas. That's under, they are just basically trigger identities. It's something that is going to make your work a lot more easier. So you can just find a table of identities and just try to make sure that you know the addition and subtraction formulas. Those are really going to help you a lot. So I think there are those where if you have cos, I think it's written as cos a plus b, okay, cos a plus b, which is going to be equals to cos a uh, cos b. Then you have minus or plus sine a sine b. Then for sine a plus or minus b, it will be equals to sine a cos b plus or minus cos a sine b. So these, they are very very important. We use them a lot, so just have them at your fingertips and they're really going to help you a lot. Okay, so that was to help you with question 1E and 1F. So you just work it out and at least be also familiar with angles like for example what maybe cos 45 is, or maybe, but it's usually the angles that we use the most. It's either it's pi, 2 pi, 3 pi over 2, or pi over 2, like 90, 270, 180, 0, and 2 pi, which is 360. So there are those that are going to give you something that is pretty much exact. So that was that about question one. Then question two is asking you to find the inverse Laplace transforms. So guys, this topic is very very simple, very very simple. If you have never gotten an A before, This is a course where you get an A for yourself. It's very simple. All you have to do is just to be patient and take things step by step. Like just follow things step by step and try the best you can to be fast. Okay? Be fast and not don't make a mistake. So for inverse Laplace transforms, also is just the the exact opposite of what we are just from doing. Okay, so we were saying if you are looking for the Laplace transform of f of t, okay, um, of f of t, this is just going to give you f of s. Then the inverse, okay, inverse Laplace transform of f of s, this will just give you back your what, your f of t. So what are the things that you have to take into consideration, or that if you want to remember certain things to help you as you solve such questions is firstly, okay, you have to know the table of Laplace transforms. For example, if I know to say from the table of Laplace transforms, if I know what t to the n is, it gives me, let's say, n factorial divided by s, then you have n plus 1 here. If I see anything that looks like something like that, I'll be able to tell to say, oh, this is just t to the n. Okay, so the table of Laplace transforms, I'll just say table of transforms, or just basically, if you have solved a number of questions, you know what the transform is for sine, for cos, hyperbolic sine, hyperbolic cosine, e to the t, even t itself, including constants and the like. If you are familiar with those, then it will be very easy for you to work around the inverse. And another thing that you have to also be aware of, something that is a must, you have to be able to break down questions into what, into partial fractions. Okay, I'll just say partial fractions decomposition. So that part is very, very, very critical, decomposing into partial fractions, because you're going to have questions, they look let's say somewhat like this one, and you can't really say you're going to apply convolutions just here, and you can go ahead and just use partial fraction decomposition to break it down. So on amongst these that we have here, we have a up to I as well. No, 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 it's a up to k. So someone to pick a question that we can work out. J. So it's 2s divided by s squared plus 6s plus 25. So you have 2s divided by, I hope I've picked the right one. That's s squared plus 6s plus 25. S squared plus 6s plus 25. So here, are we able to factorize the denominator? I don't think so. So what we can do is we can complete the square. Oh, I even forgot to mention. You can also complete the square if you have such an arrangement as the quadratic equation that we have here. So we have, if we complete the square for the denominator, we have like s squared plus 6s plus 25. Completing the square for this is just going to be s here. So if there's anyone who isn't familiar with completing the square, this is how you can simplify it. You have your quadratic in that form. This is just going to be, well, let me say, if you have, how is this going to be? So always ensure, okay, always ensure it's in this, is in the format where I'm going to use s here. We have s squared. Then here I'm going to use plus bs plus c. Always ensure it's in this format. So how you complete the square, I'm going to generalize it based on this one here. So this is just going to be, you're going to pick s, then pick the sign that you have here. Okay, pick the sign that you have here. If it's a minus, pick a minus. If it's a plus, pick a plus. So for example, if you have a plus here, you're going to say plus. then what you have here is your b. You're going to put b, you close your bracket, squared, minus, you open the bracket again, sorry, not just b here. We're going to say b over what? B over 2 squared. Then you say minus b over 2 squared, like this. So this simply means you have completed the square. So for this one, we're going to put s. Okay, we have s here, plus, because we have a plus here. Okay, we have a plus. Then this is our b term. B divided by 2, which is 6 divided by 2, is a 3. We close, squared, minus. It simply means, again, you're saying 6 divided by 2 squared, which is basically 3 squared, and it's a what? It's a 9 plus 25, like that. So what does this simplify to? You have s plus 3 squared. This will be plus uh, minus 9 plus 25. Is it 16? We'll have plus 16 there, like that. Okay, minus 9 plus 25, we have 16. So it simply means that's basically what we can substitute right here on what? On the denominator. Why did I even just go straight to think of completing the square? Well, I can't factorize it, meaning, because if I'm able to factorize it, maybe I'm able to use partial fraction decomposition. But if it's something that I can't factorize, it simply means I can complete the square. Then, and usually if you complete the square, the inverse, it has a shift. It has a shift, and it's most likely a frequency shifting shift. Okay, so here if you place s plus 3 squared plus 16, like this. So what I would do is that on this part, I will try the best I can to write this question in such a way that it's convenient with the way I want it to be. So right now, the way it is on the denominator, I've already agreed with myself to say it's a what? It's something that I use the frequency shifting for me to reach where it has reached here. But there is a catch. Okay? You have a 3 here. So it simply means whatever the function f of t was, here I had e to the minus 3t, like this, because it's supposed to be e to the 8t, then f of t. Simply means you have f of s minus a. But because where I have because here I have a plus 3, not minus 3, it simply means minus itself, I mean, it simply means the 3 itself initially was minus 3, so that if you say s minus minus 3, it becomes what? F of s plus what? Plus 3. So it simply means, like, from your f of s, where there's s, substitute with s plus 3, and that's where the s plus 3 is coming from. But if you have an s on the numerator and you're not saying s minus 3, meaning there's something that is missing, and you have to write it in such a way that it follows that. So how do we do this? So I'll just write this is equals to, allow me to pick this 2 and place it outside, like this. Then I will say on the numerator, let me write the denominator in advance, which is s plus 3 squared plus 16. So on the numerator, I'm going to put my s like this. Then I'm going to do something that changes the way the expression is looking, but I'm not changing the meaning. I'm going to put plus 3 minus 3, like this. Have I changed anything? No, I've changed the way it looks, but I haven't changed anything, because this is basically a 0, right? Like plus 3 minus 3 is still a 0. So what I would do here is that I'm going to separate this. I'll have 2, then I'll say s plus 3 divided by s plus 3 squared plus 16. Then I'll say, I'll pick this minus here, minus 3 over s plus 3 squared plus 16. You close your bracket. What follows now is that I think I can go ahead and find the inverse Laplace transform here. Okay, so from what we have, so all this that we have here, it has brought us to this point. So let's say I'll put the 2 on the outside. Okay, I'll put the 2 on the outside. If you distribute it, then inverse Laplace transform of, let's pick this guy and place him here. Okay, then I'll say minus again this 2. So allow me to use this 2. If you multiply 2 by this 3, you're going to have a 6. So I'll just put 6 on the outside, then inverse Laplace transform um, of that part, but I have to get rid of this 3 on the numerator, so that I just place a 1 here like this. So um, that's what we have. So for this one here, we'll have 2. Then something I know is that this is e to the minus 3t. What was my f of t? My f of t was cos. Here you just, that is a squared, meaning your a is a what? Is a 4t like this. Okay? Then what about this other part here? So I'll say minus 6 here. Then I'll say e to the, it's also the same, minus 3t. Then this appears to be a sine. Okay? It's a sine 4t as well. But there's a catch, right? Because when you're looking for the Laplace transform of sine, if you have sine 8t, you're going to get a over a squared plus what? Plus a squared. So it simply means on our numerator we're supposed to have a, and what is our a? Our a is 4 and it's missing. So the only way that this 4 that's supposed to be on the numerator might have cancelled out is if it was on the denominator, if it was like divide by 4 like this, of which you can write this as you can simplify as 2 into 6 is a 3, then there is a 2, so you have like 2e to the you can actually just do this. I'll say e to the minus 3t since it's common. Then I'll say 2 cos 4t minus 3 over 2 sine sine 4t like this. So if you have observed, we have manipulated the question in such a way that it works in the way that we want it to work. So when you solve these questions, don't allow them to shift the way you are thinking. Just write it in whatever way that is going to work for you. So like the format of the question has to respect what you are thinking, and whatever you are thinking has to make sense. So whatever we have done here, if we reverse this, we are still going to get back to what we have here. So that's that about the inverse of j. So the others, if you look at question k, it's also similar. Okay, you just have to complete the square, and for this one it's actually easier in some sense. Okay, it also requires a little bit of work. So question k, I mean 2k 2e, you have to complete the square for the denominator. Then f, you have to use partial fraction decomposition. Then b, c, a, d, um, as well as g and h, those are straightforward, but they also have a shift. Like those, more especially g and, yeah, g and h, they have a shift. Then I, you can use partial fraction decomposition. There is still going to help you out. Okay, so let's go to question 3. So uh, for question 3, the question says solve the following initial value problems by using Laplace transforms. So how you work these out is just a matter of uh, knowing a few things about how you find Laplace transforms of IVPs. So one thing that you have to understand about Laplace transforms of IVPs is that suppose you have let's say suppose you have suppose that you have f, let's say again comma f prime prime all the way to f to the n minus 1, and let's say what you have, this arrangement here, let's say those are continuous functions, and let's say f to the n, is a piecewise continuous function. So I believe from a sketch we're able to tell what a piecewise continuous function is. So if let's say this is our vertical axis and we have our horizontal axis like this. So if I'm talking about a piecewise continuous function is, let's say I draw it like this, that's a function. Then somewhere here I draw another one. Then somewhere maybe on top I draw another one like this. So observe to say we have a set of three functions. There is A, okay, there's A, there's B, and there's C. So A starts from, let's say it starts from here all the way to here. Then just at that point, because it's either this one has an open circle, then this one might possibly have a closed circle, then it goes to this one, maybe closed circle, open circle, like that. So an arrangement of all of these, let's say it's f of t, it will be equals to A plus what, B plus what, plus C. It's a combination of all these three, and they are going to have intervals, each of them, your A, your B, and your C. And you're going to see that in a short while when we do Laplace transforms of step functions. So what we do here is I'm going to give you uh, two expressions that we use. I'm not going to bore you with the generalized expression, it's too long. We're not even going to use it anyway. So usually we are looking for Laplace transforms of differential equations. You did differential equations in 2110. Then if let's say you have the first order where like the highest that you have is y prime, or second order y prime prime, like that. So if you are looking for the Laplace transform of y prime, okay, this is just going to be equals to s by y of s minus y of 0, like this. And one thing again that you also need to note that is very very important is that when you're dealing with, when someone says that's an IVP, it's going to have an initial condition. So a differential equation uh, is only an IVP if you're given an initial condition. And for these, always be careful. Ensure to say your initial condition is what is starting from 0. If it's not starting from 0, that's a whole different case. You don't just solve it direct as we are doing for this. Okay, I worked on a video I think last year where we had one or two questions that were not starting from 0. I'm going to share it after this class. Okay, so this is the arrangement if you're looking for the Laplace transform of y prime. So then if let's say it's y prime prime, that's our second order, this is going to be s squared y of s minus s y of 0 minus y prime of what, y prime of 0. So these two here are very 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 important. We are going to be using them as we solve these questions. Okay, so we have this one, let's just place it there, and this one, let's just place it there. Then again, when you are solving uh, when you're finding solutions for differential equations, or IVPs in this case, using Laplace transforms, the expression that you're going to get to be in terms of what, y of s, but not to say this is not what you're looking for. What you're looking for is basically y of what, y of t. So when you find your y of s, find the inverse, then you get what, you get your y of t, and that's going to be your answer. So I'm going to find my y of s, then the inverse will see. So anyone to pick a question amongst these that we have. Question 3 has A, B, C, D. Anyone to pick one of your choice. So if perhaps you are studying and there's one that you are stuck with, this is a chance for you to know how to go about it. Anyone? Anyone to pick a question? Question 3, there's A up to D. Which one are you going to use as an example? Emmanuel, you were saying something? Okay, B. Okay, let me see if let's see if I can accommodate both of them. You're saying C and D? Okay, so let me go to C. So C is y prime prime plus 4y. Um, then what do we have here? That is equals to 8e to the minus 2t. 8e to the minus 2t. Okay, so the initial condition is both of them are 0. So y of 0 is equals to 0. Even y prime of 0 is also equals to 0. So here we'll say the Laplace transform of, I'll say y prime prime plus Laplace transform of, there's a 4 here by the way, y, just y, yeah. Then here you have 8 by Laplace transform of e to the minus 2 t like this. Okay, so for this side we are going to have so for this one it just takes this one here. Okay, so it's basically s squared by y of s minus s y of 0 minus y prime of 0 plus 4. And by the way, the Laplace transform of y is just y of s, so it will be y of s like this is equals to 8. Laplace of this is basically, you say 1 over s minus a, but our a is minus 2, so that will be plus 2. So it's just um, 8 over s plus 2 like that. Okay, then here observe to say if we substitute our initial conditions, y of 0 we have been told that is 0, y prime of 0 is also 0, so we can forget about these two guys here. Okay, then what remains is that we can just factor out our y of s. So have y of s like this, open bracket, we have s squared, um, we have s squared plus 4, that would be equals to 8 over s plus 2. Um, then we can just make y of s the subject of the formula. Y of s will be equals to, we have 8 divided by, I'll put s plus 2 here, then s squared plus 4 like that. Okay, so it's just now the matter of finding the inverse of that. So if we say we have 8 over s plus 2, then s squared plus 4 like this is a quadratic, so what format is it going to take? So for the first one we can just say it's a over s plus 2, um, s plus 2, then plus here I think it's going to be bs plus c divided by s squared plus 4. Is it? Okay, so I think that's the format is supposed to, that's the format we are supposed to take. Then anyway, if it's not correct, then we'll still confirm. So here, if we multiply both sides by the denominator, we have 8. Here you have a, then that will be s squared plus 4 plus bs plus c multiplied by s plus 2. So that will be 8 is equals to a s squared plus 4a plus bs squared plus is it 2bs plus cs plus 2c. Have I done the correct thing? Bs squared 2bs, then cs and 2c. Okay, so that's what we end up with here. So we can just write it there. So that would be as squared plus 4a plus bs squared plus 2bs plus cs plus 2c, like this. Then so this one and this one, we can equate them to 0. So it simply means we can say our a is equals to minus b. Then for constants, we have this one and this one here. Okay, so we have 8 is equals to we have 4a plus 2c. Then there is this one and this one. Those are also going to equate to 0. Okay, they are going to equate to 0. So we are saying 2b plus c is equals to 0. Okay, so from here, maybe I can say c is equals to minus 2b. Okay, let's see how this turns out. So if we put 8 is equals to 4a plus 2, then minus 2b, this will be 8 is equals to 4a minus minus 4b. Okay, then you have 8 is equals to, where there's a, if you plug in minus b, that would be minus 4b minus 4b. That would be 8 is equals to minus 8b. Your b is equals to negative 1. So we'll have to confirm all of this. So if b is equals to positive 1, meaning a is equals to negative 1, then c is equals to, no, was b negative 1 or positive 1? No, it's negative 1. So simply means your a is the one that is positive. So your a is the one that is positive 1, then your c is going to be positive 2. So let me just see if this is correct. So we have we said a over s plus 2 plus bs plus c divided by s squared plus 4. So if we say 1 here, s plus 2 plus our b is negative, so that would be minus s. Then our c is positive 2, like this. We have s squared plus 4. That's negative. Then this is going to be s squared plus 4 minus, we say s, just a minute. So let me just say maybe plus s plus 2 multiplied by 2 minus s divided by s plus 2 s squared plus 4. That will be s squared plus 4. Then this by this, it will be plus 2s. Okay, you have 2s here. Then this and this is 2s. Then this and this is 4. That will be plus 4. Then this and this is minus s squared. Okay, then here 2 times minus s is minus 2s. So in the numerator, this cancels with that one, this with this one. So yeah, so it's correct. Okay, so our y of s is, it happens to be 1 over s s plus 2. We say s plus 2 there. Then we can say plus, since our b is negative, then our c is positive. I'll just say 2 minus s divided by s squared plus what, plus 4. Actually, this one we can write it as, I can just put a negative here instead. Then this becomes a positive and this becomes a negative. So meaning I can say it's minus s minus what? Minus 2 divided by s squared plus what? Plus that. Okay, then all we have to do now is that it's just to find the inverse of this. So observe to say even this one here we can break it down. Okay, this is just going to be like minus s over s squared plus what? Plus 4. Then there will be a plus here. Okay, there will be a plus 2 over s squared plus what? Plus 4. So that's the arrangement that we are going to have. So we'll have minus s over s squared plus 4 plus 2 over s squared plus what? Plus 4, of which this one, can we, no, no, we can't arrange it with that one. We can't write them as a single fraction. So the inverse of this, okay, the inverse of your y of s, your inverse of y of s just gives you y of what? Y of t, which is just going to be equals to this one is supposed to be a sine, okay? But um, the way it is that if you say it's sine the square root of 2t like this, even on the on the numerator simply means you are supposed to have a, which is what? Which is just a 2. So this is supposed to be divided by 2. Then what about this one? That will just be minus, it will be a cos, so it will just be cos 2t, since that's a 4. Then you say minus here again. So for this one it's just sine what? Sine 2t like that, and this is your solution. So all you have to do is to always remember to say, like, find using this to find your Laplace transform is very easy, but it doesn't end when you find your y of s, like when you make it the subject or the formula. It ends when you find the inverse of this one to get your what? To get your y of t, because that is what you are looking for. Okay, so that was that about question 3. So there are 8 questions remaining. Then question 4 says sketch or graph the given function which is assumed to be 0 outside the um, given interval. Represent the following functions using unit step functions and find their Laplace transforms. So something about this that is maybe simplifies the work is the fact that if you're looking for the Laplace transform of, let's say you have f of t minus c by u of t minus c like this. This is just going to be equals to f of s multiplied by e to the minus cs like this. So this actually completes everything here. So when it comes to sketching, okay, for example, let me just quickly use um, question 4a as an example. And by the way, question 4g and h, I've already put it on the channel. You can check it out. I'm sure maybe some of you have already seen them. I've worked out question 4g and h. So let me use question 4a as an example. So we have f of t is equals to, we have this piecewise arrangement. We have t here. We have 0. Then the interval we are given is 0 to 2. Then for t greater than or equals to 2. So the way this is, if you want to sketch it, is it's going to be something like this. So let's say this is our vertical axis and this is our horizontal axis. Okay, so what I have here, I'm going to say not really y-axis, but let me say this is my f of t, right? Because we have f of t is equals to t. So let me say this is my f of t axis and this is my t axis. So one thing that you observe here is that this type of function, I believe we're able to remember that is called something like an identity function, because for your whatever the input is, that's what your output is. If my input is 1, even the output is 1. If my input is 100, even my output is going to be 100 as well. Okay, so just give me a minute. Just plug in my device. Okay, sorry about that. So this is an identity function. So when we plot this one, it can be somewhat like that. It's at a 45 degrees angle, I think. Uh, okay. So it can be something like that. So this right here is our what? Is our f of t is equals to t. But um, look at this, yeah. We are given this interval, which we can write as we have the square brackets indicating to say is less than or equal to 0, meaning 0 is part of the interval. We did this in first year, I believe, and is it set? Yeah, I think so. Forgotten, it's been a long time. So here we have a 2. Because we have just less than here, it simply means we just put parentheses like that. So this information that you have right here is very, very important. It's very easy to get the sketch wrong if you ignore the part where the question says sketch or graph the given function, which is assumed to be 0 outside the given interval. So meaning outside the interval, I mean, we are supposed to respect that particular part. So let's say because the interval that has been given is starting from 0 all the way to 2. So let me say this is 2 here. Okay, let's say this is our 2, meaning the endpoint would be somewhere there. Okay, it would be somewhere here. So because this 0 is part of the interval, it simply means we can put a shaded circle here. Then the 2 is not part of the interval. What can we do? We can just put what? An open circle like that. Okay, I can just put an open circle like that. Okay, so that's the sketch that was supposed to that we were looking for. Then the second part of the question um, says we have to represent the following function using unit step function. So this here is let me try to generalize it this way. If you have let's say you have your f of t equals to, let's say you have two functions of t, you have a and b here, like you have two of them. So this part that I'm about to show is very, very important. It's going to simplify your work when it comes to unit step functions. Writing unit step functions as unit step functions. So if you have a and b, let's say a and b are functions of t. So here let me use n. Let's say n less than t less than m, like this. Then where you have t greater than or equals to what? Greater than or equals to m. So if you're writing this as a unit step function, you're going to have your f of t is equals to, you put your a here, open bracket. You're going to say u of t minus n minus u of t minus m, like this. Okay, like that. Then we're going to say plus your b there. Then you do the same here. You have your u of t minus m, like that. Okay, so this is just more like a something general, just to give you a picture of the way you write this. But what's really nice is that in most cases they put a 0 here, so this part is not usually included. Like it's just the first part. And again, there are times where your n is equals to 0, such as what we have here. If your n is equals to 0, this portion right here can be just indicated as a what? As a 1. There is no harm. So this part you can indicate it as 1 if and only if your n is what? Your n is a 0. If it's not a 0, follow this general format that I've given you here. Okay, so if we do this, for our question here, we'll say our f of t to be equals to, we put our t, let me not erase this part, let me just leave it. So we'll say our f of t is equals to, we're going to put t on the outside, uh, in the brackets. So I said if you want, you can just put a 1. Okay, there's no harm. So do I really need to explain why you need to put, why you can put a 1? Okay, if you want to know why it's okay putting a 1, I'll try to save time, and you can just come in my inbox after the class. Maybe I'll explain to you. Let me just not to say you can put it like this. Even if you say u of t minus n, let's say your n is a 0, you just end up with u of t like this, of which, observe to say sometimes they don't write them in this format. They would say u of n t like this. So it simply means right here what you have is a what? Is a 0. So remember, you're going to find the Laplace transform like that. So let's say you multiply, then you have like, if you distribute this one by that one, you're going to have u of t minus 0 here, which is just u of t like this, meaning what you have here as your shift is a 0. So you're going to say the Laplace transform of t, in this case, which is my f of s, it will be equals to 1 over s squared, right? Multiplied by e to the minus cs. What is your c? Your c indicates the shift. In this case, here is your m, your n. Here is your what? Uh, there is your m. So it simply means for this particular question, I mean this particular part, the shift was 0. So if you put a 0 here like this, you just end up with what? Any number raised to the power 0, like anything is just 1. So that would be just 1 over s squared. No wonder I said for this part, if this is 0, you can just indicate what? Just indicate the 1 here. There's no harm because of this outcome that we have seen here. So that is the answer, in case maybe someone was wondering why we can put a 1. So we can put a 1 here minus u of, we'll say t minus, what do we have? It's a 2 here like this. So what do we do? Expand. We have t minus t, u of t minus 2. So it's easy to find the Laplace transform of this, but what about this one? So one thing that you need to know is that if you're finding Laplace transforms of step functions here, when you have it as a unit step function, only proceed if and only if the function f of t has been shifted by the right amount c together with what? With what you have here. If you observe, this is just t. So it's more like you said t minus 0 by u of t minus what? Minus 2. This is a 0, this is a 2. What does it tell you? This has not been shifted by the right amount. What do you have to do? You have to shift it. So this would be like t minus, do anything that you can to ensure it's shifted by the right amount. I'll write it a little bit different, but I'm not going to change the meaning. I'll say t minus 2 plus 2 here like this. Then you have u of t minus 2 like that. So you're going to have t minus, I'm going to expand, right? So this negative, I'm going to distribute by this part as well as what? As well as that part. So, and including this one here. So that would be minus, I'll say t minus 2, then u of uh, t minus 2, then again minus 2 u of t minus 2 like this. Okay, that's something that you have to, this is what we have done here. We haven't changed anything. So this negative sign, we have it here, and we also have it right here. So I feel like from where we are at right now, we are able to find the Laplace transform. So our f of t has turned out to be t. Okay, this is really going to save my time. Let me just copy it and place it right here. So now, here to say the Laplace transform of our f of t is just going to be equals to this one. What did we say? It's just 1 over s squared. Then for this portion, just find again your Laplace transform of what? Of just t. All we were doing it was just to ensure that it's shifted by the right amount. So here we'll just say minus your t, the Laplace transform is this same one, but remember there is this that is going to result into having that would be like e to the minus minus, what is your c? Your c is a 2, s divided by s squared, minus the Laplace transform of a 2 is a constant. So don't just find for this one here. I once made that mistake. So consider to say this is your f of t. Okay, your f of t is in this case is a 2. What is the Laplace transform of 2? Is 1 is 2 over what? Is 2 over s multiplied by e to the minus 2s, like that. Okay, so if you want, you can choose to leave it the way it is. If you want, you can choose to simplify it. Whichever you do is still very much okay. So any questions on this particular part before we go to the next one? Do we have anyone with any question? Okay, the silence means people have understood. Okay, so we proceed to question 5. Okay, how many questions remaining? Four more questions. Okay, so question 5 is just the opposite of what we are doing. I don't think there's really much to talk about on question 5, unless if someone has a question, because um, it's just basically the opposite of what I'm just from doing. And is there anyone who has a question on something to do with question 5? Yeah, no, it's being recorded. I'm going to upload it as soon as we are done. Then I'll make it public. It will be on the second channel. I'll still share the link. Yeah, sure. So honestly, because I've talked about the inverse on part question 2, and I'm from doing question 4, question 5 is just a reverse of what I'm from doing, just like I did on question 3. So okay, let me let me pick question 5a, that is e to the minus 2s, e to the minus 2s divide by s plus 2, then to the power 3, like this. Okay, so for me, when I'm answering these questions, I try the best I can to see the question for what it can possibly be. Okay, so okay, let's just eliminate the fact that we have this one, right? Like we have this guy on the top, of which it simply means it was a step function. It was a unit step function. So if you have 1 over, if you're looking for the inverse of 1 over s plus 2 to the power 3, like this, I think one thing that I can think of is that the fact that I have a power 3 here, this might have come from t to the power 2. Okay, this might have come from t to the power 2, but when you say t to the power 2, you get like 2 factorial divided by s to the power 2 plus 1, of which this is going to be 2 over s to the power 3. This is the Laplace transform of t to the what? T to the power 2. Then observe to say I have a plus 2 on the inside. It gives me additional information. This tells me to say, oh wait, it actually means this had a shift. It was multiplied by some other function, and that function is an exponential function. It's more like, remember, the frequency shifting, we said if you have e to the at of f of t, this is just going to be f of s minus what? S minus a. So it simply means you get your f of s. Where there's s, substitute with s minus what? S minus a. But I know someone is thinking to say, but if there's a minus here, why do we have a plus here? Then why should I think about um, to say there was a shift? I mean, if there's a plus here, it obviously means there was um, there was a minus. It's supposed to be e to the minus at, meaning your a is a negative value. Okay, it simply means your a is a negative value. So uh, it's more like you had e to the minus 2 because you have a 2 here. It's simply a 2, so that would be minus 2s, then t to the power 2 like that. Okay, that tells us what we have. So this right here is the inverse of what? Of this one. But what about taking this part into consideration? It simply means you had u of t minus what? T minus 2. And the proper way to write it is in this way. We'll say the inverse Laplace transform of e to the minus 2s divided by, we have s plus 2 to the power 3. So the first thing that I do is that I lessen the burden here by just isolating this guy, then just considering 1 over my denominator, then I find the inverse. Then after that I determine that this is e to the minus 2s, then I have t here. But because it was a unit step function, I'll just say t minus a 2, then squared e to the, not that, um, but u rather, u of t minus 2 like that. Okay, so this is basically that. So it's just a reverse of what we are doing. So I think something that can actually work for you is just isolate this, the e to the minus whatever it is, maybe just e to the minus cs, whatever c is, for that particular question that you'd be doing. Then focus on just your f of s. Find the inverse of f of s, then write it in such a way that you bring back the u of t minus 2. Then just ensure to say where you have t, just subtract your c that is indicated as of this one there. Okay, then um, that was question 5. We have 3 more questions remaining. Someone has a question? Daniel? Yes, Daniel. Yeah, I can hear you. The Okay. Oh, yeah. Sorry. I'm supposed to put t, not s, right? Oh, yeah. Thank you for that observation. So I misplaced s with I mean t with s. Yeah, thank you, Daniel. So we have 2, then we say t minus 2 here. Then we have t minus 2 squared u of t minus 2, like that. Okay, so that's basically that. Then Going to question 6 is just a blend of question 3 and question, is it question 3? Yeah, it's just a blend of question 3 and question 4. Is it 4? Yeah, question 4. That's what question 6 is all about. So one thing that is actually very convenient here is that this tutorial sheet, all the initial conditions here, they are starting from 0. The time that I did this course in 2024, we had some we had some conditions that were not starting from 0, like they would start from, let's say, 1 or come again. Okay, sure. Yeah, so I was saying you'd have initial conditions starting from either 1 or starting from pi, depending on what you have. Okay, so question 6b, as our colleague is requesting, is y prime prime minus y is equals to, we have e to the t, we have 0 here. Then the interval is, we have 1 here, then t greater than or equals to 1. Then the initial conditions is y of 0 is equals to 0, y prime of 0 is equals to 1. So y of 0 is equals to 0, y prime of 0 is equals to 1, like that. So whichever side you start with is up to you. So let me start with my left hand side. Um, so here we say the Laplace transform of y prime prime minus the Laplace transform uh, of y. So this is going to be equals to s squared y of s minus s y of s minus y prime of s minus y of s for this one here. Okay, so our initial conditions, y of 0 is a 0, so if we forget about this one, then for this part we have a 1. So um, how can we write this? So this would be, if we factor the y of s, we are going to have s squared minus 1. That comes from this one in this one. Then we have minus 1 from this part here. Okay, so we can save that solution and find the Laplace on the right. So we have y of s, then we have s squared minus 1 like that. Okay, then for our right hand side, we have let's say we use f of t is equals to, it will be e to the t. Because we have a 0 here, we can put a 1. We say minus u of allow me to just put a 1 here, u of t, like this. So this here is the same as writing it as u of t minus 1. So whichever way you write it is still okay. So here, if you expand, that will be e to the t minus e to the t. Okay, let me write it as t minus 1 like this. So this guy is okay just the way it is. Then for this one, it's not been shifted by the right amount. So here you can say e to the, I'll say t minus 1 plus 1 u of t minus 1 like this. So one thing about these here, it's more like if you have a to the x multiplied by a to the y. This is going to be a to the x plus what? Plus y. It's indices, right? The bases are the same, so you add the powers. So this arrangement here simply means you had it's more like you had e to the t minus 1 multiplied by e to the power 1, like that. So you're going to have e to the t minus, I'll just say e, okay, then you have e to the it's multiplied by here e to the t minus 1 u of t minus 1 like this. So this one, I guess we're just treating it as a constant. It's just that more like the coefficient. So we have e to the t minus e here. Allow me to write it like this: e to the t minus 1, then u of t minus 1 like this. So to find the Laplace transform, so we just say Laplace transform of this over f of t. Allow me to just be a little bit jumpy here, but when you're writing it on your paper, is it tomorrow, just write like this as many steps as you can. I mean, all the steps just indicate on your paper, just in case you make a mistake, they'll be able to maybe mark you from somewhere. So this one here, it comes from the fact that the Laplace transform of e to the at is simply equals to 1 over s minus a, and in this case our a is a 1, so that would be 1 over s minus 1 minus this guy here. Again, for this part, I know it appears like we have this power here that maybe might disturb someone, but it's still the same e to the t, but all you had to do was to ensure that it's been shifted by the right amount, because if you just got it the way it was, it simply means we would have left out the fact that we are supposed to have a e on this side and it was going to be wrong. So I can just say it's e over s minus 1. Then this portion here gives you e to the minus s because your c is a 1. So if you want, you can combine these two together just by saying you have, let me put 1 over s minus 1, then I have 1 minus e to the 1 minus s like this. Is this okay? That is for the other side. That is for the right hand side. So what is remaining now is to equate your left hand side and your right hand side. So you have y of s, you have s squared minus 1 here is equals to let me just write this as this e to the minus 1 minus s divided by um, s minus 1. So you have y of s, then here you have s squared minus 1. This will be equals to 1 minus e to the minus, I mean 1 minus s divided by s minus 1. Then here you're going to have plus 1, which is this one. So divide both sides by this guy. So you have y of s is equals to 1 minus e to the 1 minus s divided by s minus 1, s squared minus 1, plus 1 over s squared plus 1 like this. So what is remaining is just to find the inverse, right? So your y of s will be equals to so this one right here, we can break it down into its equivalent partial fractions so that we separate it. It will be 1 um, so we are going to have this multiplied by what you are going to get here when we break it down. So if we consider uh, let's say this part here, because even if we say it's 1 divided by s minus 1, s squared minus 1 minus e to the 1 minus s divided by s minus 1, then you have s squared minus 1 plus 1 over s squared plus 1. This is simple because that's just is it sine? Yeah, so this is a sine when you find the inverse, so we can just focus our attention on these two. So for this one, if you break it down, if you have 1 over s minus 1, s squared minus 1, that would be equals to, let's say, a over s minus 1, that would be plus bs plus c divided by s squared minus 1. So that would be 1 is equals to a s squared minus minus 1 plus bs plus c, then s minus 1, like that. Then this would be 1 is equals to as squared minus a plus bs squared minus bs plus cs minus c. I hope I've done the correct expansion there. Bs squared minus bs, then cs minus c. So clearly here from this one and this one, it tells us that our a is equals to negative b. Then from this one and this one, we have minus a minus c is equals to 1, minus a minus c is equals to positive 1, of which we can say is just say is a plus c is equals to negative 1, or even like this is fine. Then from this guy and this one, what do we have? We're going to have minus b plus c is equals to 0, meaning your b is equals to c, or c is equals to b. We can say minus a minus b, right? Because c is equals to b, that would be equals to a 1. Then what is your a there? We said a is negative b, is it? Isn't this going to give us a 0? What is that going to give us? Did we use the correct decompositions? Anyone? So we have how did I write it? Yeah, we have we have 1 over s minus 1, uh, then s squared minus 1. That's a quadratic, so that appears to be the correct format. So if we plug in, since we have minus c, minus c, I mean minus a minus c is equals to 1, where the c, since c is equals to b, that's going to give us a 0 for that part, of which I'm not convinced. Has anyone gotten something different? Okay, so maybe let me use a different approach in terms of decomposing this one. Let me say I have 1 over I have 1 over s minus 1, um, then I have s squared minus 1, like this. Let me use just constants on the numerator. Um, so for this part here, okay, for that part, let me try to write it this way instead. So since we have like s squared minus 1, I can write this as s squared minus 1 squared, or which can be like s squared minus I mean like this, s minus 1, then multiplied by s plus uh, s plus 1 like that. Okay, then it simply means for this part we're going to have 1 over, we have s minus 1, then s minus 1, s plus 1, that is going to be equals to that will be s minus 1 squared, then I have s plus 1 like this. So I feel like that one is going to work out compared to what I had earlier tried to work out. So this is now what I'm going to use, and the decomposition that I'm going to write is, I'll say a over, I'll start with this one, it will be s minus 1, then plus uh, b, I'll say s minus 1 squared, plus c over s plus 1 like this. Okay, so meaning you have a is equals to 1 is equals to a here. So what are you going to have? So this would be s minus 1, then s plus 1, plus b s plus 1, plus c s what is it, s minus 1 squared like that. So now it's just a matter of expanding this. So for this part, if you say s squared, that would be s squared plus, is it minus 1? Yeah, it will be minus 1. Minus 1, so it will just be a s squared. Okay, as squared minus a, plus you just have bs plus b, plus then this part, what do we get? When you expand, it will just be like c, you have s squared minus 2 cs plus what, plus c like that. Okay, so this and that, uh, you have 0, so it simply means your a is equals to minus c, then you have this, and that is also equating to 0, so you have b is equals to um, b is equals to c. Okay, so that basically gives us 3 equations. Then the last one is going to have constants, that is a 1 is equals to b minus minus a plus this c that you have on the last part here. Okay, so one thing we observe is that our a is equals to minus c. Okay, our a is equals to minus c, so we can say we have 1 here is equals to um, or maybe let me try to do it the other way around. Can it work? Okay, where there is b here, let's plug in c, since we know what c is, we know what b is, we put c there, minus a is minus c like that. Okay, then what do we end up with? What are we going to end up with there? No, I think there's something that I've forgotten here. This one here, where is it? This one and this one from here. It's 2c. So we have like b minus 2c is equals to 0. So meaning b is equals to positive 2c. So that's what we are going to plug in here instead. So we have 1 is equals to 2c. This times this is going to be positive, so that will be plus c, meaning 1 is equals to 4c. C will be equals to 1 over 4. So from here, since we know that b is equals to positive 2c, b will just be equals to 2 over 4, that is going to be 1 over 2. So b is equals to 1 over 1 over 2. Then our a is equals to negative c, so a is equals to negative 1 over 4. So uh, that's what we have. So our y of s is equals to, um, since our a is negative, you have negative 1 over, we said it was s minus 1. Then our b is positive, so we have 1 over, and by the way there is a 4 here, we say 2, that would be s minus 1 squared. Then our c is also positive, it will be plus, um, our c is also 1 over 4, so it will be 1 over, we put 4 here, then that will be s plus 1, like this. So this is how we decompose this one, and we can find uh, the inverse Laplace transform. So we still have the 1 over s squared here, which we already know is easier to find. But when it comes to this one here, since it's the same, it's more like this one is going to multiply by everything here, but this here is just for this one. Okay, so it simply means you also do the same for what, for this one too, which I think is going to be y of s is equals to, um, this one here the way it is, you can place it here, then plus, then this one again the way it is, because when you decompose, when you try to separate this one, you just put it on the outside, like separate, uh, then you decompose just the denominator, to see what it is equals to, regardless of whatever the numerator is. You're just going to bring back your e to the minus, e to the 1 minus s. So you plug it here, 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 then you try to um, work it out. And how is that going to turn out? So for these are straightforward. That's for this is just for e. Um, this is for t, and that's for e as well. But they are going to be shifted. So this was pretty complex than I expected, but if you just take it step by step, you're still going to arrive at the answer that you're looking for. Are we able to find the inverse from this stage? Okay. So here, whichever side that you work around with, so when they give you, what do they call this? They say it's an IVP with a discontinuous force. So it's just a combination of the two. So it's just making sure you equate the right hand side and the left hand side. Then you are going to indicate it as what, as your y of s. Then from that y of s, you have to get your what, your y of t. And in your question, it's either they're going to give you something complex, it's either on the right hand side or on the left hand side, but you're most going to likely use partial fraction decomposition for you to be able to work it out. So try to know all the formats that you can use for partial fraction decomposition. They're really going to help you a lot. As you observed, I tried the other one, it didn't work out. It's giving me zeros, of which that's not supposed to be the case. I think you can even tell to say this is not what I'm supposed to get. So if you just say, okay, I'm getting a is equals to 0, so meaning it's 0, you're just going to get something wrong that you're supposed to get correct. So no different formats that are going to be convenient for different type of setups. Okay, then when it comes to um, question 7, and question 8, we are using convolutions here. So one of the standard things that uh, you can keep in your mind as of the way convolutions work is that if you have, let's say, the Laplace transform of, let's say, f of t, then we use this star to indicate the convolution of g of t, this is simply going to be equals to f of s by g of s, like that. Okay. Okay, so we've been talking for 100 minutes. I'm tired. So this is something that you have to keep in mind about convolutions, but uh, always note to say, if you use something, if you use it as direct as this one, you have to find the inverse. Okay, otherwise you have to use the what, the convolution integral. Okay, anyone to give me the expression for the convolution integral? Like this, huh? Then you have t here, isn't it? Mm-hmm. Sorry. Mm-hmm. Tau minus t minus tau. So I feel like some functions, if not all of them, even if you swap it, you say f of, let's say, t minus tau, then you have g of tau, like that. It can still work out. Have you tried it out? Yeah. So that's the way it works out. So if when we use the convolution integral, like if we have f here, then we have g of t is equals to, from 0 to t of, as our colleague has given us there, f of tau, we have g of uh, that d tau. So let's say we, allow me to use something as simple as this, huh? So this one is more like, let's say it's more like my f of t is equals to, my f of t is equals to 1, right? Then even my g of t is equals to 1. So when I find the Laplace transform of this one, I'm going to end up with, if I say Laplace transform of f of t, this is going to be equals to 1 over s, like this. So if you observe what we have here, is this multiplied by this, meaning you're saying 1 over s multiplied by 1 over s, you're going to end up with 1 over s squared. Then if you find the inverse of this is just going to give you what? That's just going to give you t, of which if you use this, it's going to take you direct to what? To this one here. Okay. So which method would you prefer using here? But I think using the convolution integral here is much convenient because it takes you direct to what you're looking for. Sometimes it can be a bit tedious to look for, the inverse. And for from this here, one thing that you need to understand is that the inverse of the same f of s, g of s, is equals to, this is just equals to f of t, like that, then g of t, like this. So we have a up to e. Which one can we use as an example? Which one of these can we use as an example? be is e to the t. Okay, so b is e to the t. We have 1 there, so just erase this. So we have e to the e to the t, then uh, we have a 1 here. Okay, so even from the same definition that we um, from the same definition that we have, so this is going to be from 0 to t. So let me try out to work it out as it is. Let me see what I'm going to get. So if I say my f of t is equals to what is this, uh, e to the t, then my g of t is equals to 1. So someone to try to work it out using the integral, and then we compare. I believe it's as quick. Then my f of s in this case would be 1 over s minus 1. Then g of s would be equals to 1 over s. So if I have 1 over s, then s minus 1, what are we going to get there if we do it the other way around? What are you getting? Anyone? So what actually makes it simple is that from the step that we have taken, like this direct one where we just use f of t and g of t, is what is going to make question 8, the last one, very convenient, because you just pick it the way it is and find the inverse. Then from that, when you get what your inverse is, okay, it will most likely be a set of two of them. Then you're going to have to indicate them like that. So someone to try to work it out in this using the integral, then you tell me what you're going to get. Has anyone worked it out? What are you getting? Okay, so let me try to work it out. So if we have 0 to t, um, then from this definition that we have here, f of tau, then we have g of t minus tau. So the way this one is going to be is here, let's say we put e of tau, okay. Uh, then for this particular part, uh, we are going to multiply by what? We're going to multiply by 1. So I just put by 1 d tau like this. So this would have like 0 to t, then e to the tau just like this, d tau. Then what's the integral of e to whatever the power is here? Yes, so that would just be, we are supposed to divide by the derivative of the same power, which is 2 1. So that would just be e to the tau. Then we evaluate from 0 to that. That's going to be equals to um, that's going to be equals to, if you say that would be e to the t minus, if you plug in a 0 here, that would be e to the 0, that would be a 1, and that's that. So from the one that I got, which is the 1 over s, then s minus 1, if you break this one down, I felt lazy, you're still going to, when you find the inverse, you're still going to reach somewhere here. So this one here goes direct. This one takes the form of you, the way we are supposed to work out uh, uh, question 8. Okay, so talking about question 8, which is supposed to be the last question we are doing. Which one are you guys picking? Okay, let me use which one can I use here? Let me use C, 10s. What is it? We have 10s divided by s squared plus 25 squared, s squared plus 25 squared like this. Okay, so considering the fact that uh, I have a squared here. Okay, I have a squared here. Here I have 25. Then here I have a 2. This for me indicates to say, and the fact that I have a cos here. Okay, the fact that you have is this s? The fact that you have s here. So uh, if you look at the table of Laplace transforms, something that is it still applies with the what is that shift? The second theorem, which is the frequency, I mean the frequency domain derivative, which is if you have t f of t like this, that's just going to be equals to minus 1 here to the power n. Then you have f to the n of s like this. So why am I thinking of it like this? It's because um, what I would have here is if I put 10s divided by, observe to say I have s squared here plus 25 multiplied by s squared plus 25 like this, or just even the way it is like this. This s here on the inside has not been affected, so I feel like it would be a little bit primitive for me to think of maybe they applied the exponential scaling. So what I'm going to do is just to uh, what I'm going to do is just to think of this in terms of like that one there. Then how does this come about? Okay, this might have come about as a result of me doing what? Doing the derivatives, because if you have your f of s, okay, if you have f of s is equals to let's say lambda like that. Okay, so if you differentiate this one here, and it's going to be something that is supposed to be on the denominator. Let's say you have let's say it was s, yeah, let's say it was 5, because your a here is going to be your a is going to be uh, your a is going to be 5 because of the 25 that you have here. So if I have let's say if I have 5 on the outside, if let's say my f of s turns out to be s over s squared plus what, s squared plus 25. So to me, this would mean that the initial function that I had, or from this one when you find the inverse, is cos what? Uh, cos 5 cos 5t. But how come I have a what? I have a minus 2 here, because this can also be written as you have s here, okay? You have s here, then that would be s squared plus what? Plus 25. Then that would be minus what? Minus 1. What you get if you differentiate this once? Anyone to give me a derivative for that one? The first derivative. It's a product of two functions. What are you going to get? I don't know if there's someone trying to say something. I'm unable to hear you. Hello? Okay, maybe let me just try to simplify it this way. Um, Instead of us going through derivatives, just look for this. Um, if you're looking for the transform of t cos, but it still takes the same format. So if you take it step by step, you're still going to arrive at this same uh, um, outcome. So if you have this, I've generalized it using a here. This is just going to be equals to s minus a squared divided by a squared plus a squared squared, like this. Okay. So from here, this comes from the fact that you'd have an s on the numerator. This s that you have, the first thing that you can think of is that this might have stemmed from the fact that you have a over a squared plus what, plus plus a squared, like this, of which if you have a, then you have a squared plus a squared to the negative 1. What do you do if you use the chain rule here to differentiate? It would be negative. You would have a here, okay? Then the derivative of the inside is 2s. You just put 2s like this. This part reduces by 1, it becomes 2. Then you have what? You have what do you have? You have s squared plus what? Plus a squared to the power 2. Then observe to say you have 25 here. So it's possible that we said our a is equals to what? Is equals to 5, because here you say 5 squared. So now you'd come and say, okay, I have minus 2, then multiply by 5, then I have s divided by s squared plus what? Plus a squared, like this, to the power 2. Then this I know is going to give me minus 10s divided by s squared plus what? plus a squared, then you have squared like this. It's more like I'm going in reverse, but where is this negative going? Because we are using the frequency domain derivative, we have to the power 1 here. Okay, the t is to the power 1. So if you plug in a 1 here where there's n, it's more like you are saying negative 1 to the power 1, that is negative 1, multiplied by negative 10s divided by a squared plus a squared squared like this, and your answer is just going to be 10s over a squared plus a squared like this. So I've worked in reverse. So one thing that I've identified is that this comes from this comes from a over a squared plus a squared. What is my a? My a is a 5, so that is more like it's you have 5 over a squared plus 25. But what's the actual function? What's the inverse of this one? The inverse of that one is what? Is sine what? Sine 5t. But does it end here? No, because when you find the Laplace of this, you get that one, right? Then for it to reach at something that appears to be this one, simply means you had the what? You had the t here. That's where it comes in, where you do the differentiating and the like. Is that okay? Is that part okay? Okay, so that's basically that. If you guys have any further questions, what am I writing your quiz tomorrow? What time are you supposed to have your quiz? Okay. If anyone has any questions further than what we have talked about, just reach out in my inbox. I'll be able to attend to you in the quickest time possible. Otherwise, thank you very much, guys, for joining in, and I'm wishing you the best tomorrow.